All right, guys. So today, what we're looking at is what we're going to call special quadrilaterals. So special quadrilaterals. So quadrilaterals we know is four sides. These are special because they have a few rules that work for them. So matter of fact, we're going to be looking at six figures today. They're a little easy to get confused, but just pay close attention. You should be okay. So special quadrilaterals. Once again, four sides. The first one I'm going to be talking about, top and bottom are parallel. In geometry, to specify their parallel, we're going to use little arrows. Right? To specify that they're the same side, we're going to use little slashes. So these top and bottom are same size and they're also parallel. Now the sides, left and right, they're also going to be the same size and they're also going to be parallel with each other. Notice how top and bottom I did one slash, left and right I did two slashes, so you can tell not all four are the same. Yes. So once again, top and bottom are the same size, but not all four. Right? Left and right are the same size. And then this one, we're going to call this parallelogram. So top and bottom are the same, left and right are the same, but not all four. When I mean the same, I'm talking about the lengths. Notice I did the slashes to talk about lengths, and I did arrows to talk about parallel. Okay, so top and bottom are parallel and the same size. Left and right are parallel and the same size, but not all four. So not all four. Okay. Our top and bottom are parallel and the same size. So matter of fact, in geometry, to specify the same size, we're going to use the word congruent. So when I say congruent, I'm talking about same shape, same size. Okay, so that's the word we're going to use a lot. So top and bottom are parallel and congruent. Left and right are parallel and congruent, but not all four. I can do it with the slashes, or I can do numbers. I could say top and bottom are 7, left and right are 10 each. So you can do those. So once again, that's parallelogram. Now another one that we have, this one you guys might be familiar with. The top two sides are going to be congruent, not parallel, right? Because they intersect. They're just congruent. The top two are congruent. The bottom two are congruent to each other. Once again, not all four. Only the top two are equal. The bottom two are equal. Not all four. And then on the side angles, the two side angles, so the one on the left and the one on the right, those two are congruent as well. Top and bottom are not. And then that one, we're going to call it kite. Right, so top two are congruent, bottom two are congruent, not all four. These two, parallelogram and kite, are easy to get confused. But notice how in kite, the two that are parallel, they touch each other, right? I mean, the two that are congruent are, touch each other. The parallelogram, they're opposite. So they're on opposite sides. Now, another one I'm going to talk about is top and bottom are parallel. So I'm just going to use arrows to say they're parallel, but by all means, they're not the same size. So top and bottom are parallel, but different sizes. We can tell that the bottom one it's smaller than the bottom one. Right, so they're just going to be parallel. Now the other two sides are not quite parallel, and we're going to call this trapezoid. So when the top and bottom are parallel, different sizes though, but they're parallel, they're trapezoid. The two at the side, they don't have to be the same. One side could be 7, the other side could be whatever, anything other than 7. Now, if the sides happen to be the same, Let me use red for this one. If the sides happen to be the same, some cases it happens, so I'm going to use red. So I'm just saying if it happens, it doesn't happen all the time. If it happens, we're going to call this isosceles trapezoid. So a trapezoid, top and bottom are parallel, and that's all it needs. The sides could be different. Now, if the sides are equal, like I said, if they are, not always, if they are, then isosceles trapezoid. So if the top and bottom are parallel and the sides are not equal, just trapezoid. But now the top and bottom are parallel, the sides are equal, then isosceles trapezoid. From the 6 that we're going to be looking at, these are the 3 hard ones. So I figured I'll go over the hard questions first. Any questions on these 3? I guess this 4, because isosceles or isosceles trapezoid or just regular trapezoid. Any questions on these figures? No? So, matter of fact, on the trapezoids, something happens with the angles at the sides, which I'll show you guys in a minute. Something happens with those angles, but once again, I'll show those in a minute. Now, the other 3 figures, those are a little bit easier. One of them you guys are familiar with. We're going to call it a rectangle. A rectangle, what a quadrilateral, in order for it to be a rectangle, I'm going to say all the angles have to be 90 degrees. Bless you. So this is kind of like this is a special kind of a parallelogram, because if you notice, top and bottom are parallel, the same size. Left and right are parallel, the same size. So it is a parallelogram, but this is a little more specific because the angles are 90 degrees. Then we call that a rectangle. Now, another figure that we're familiar with, it's when all the sides are equal, the angles don't have to be equal, just the sides are equal. We're going to call that rhombus. When all the sides are equal. Not necessarily the angles, just the sides. So, as an example, let's say I have these 4 fingers here. They're not quite equal, but for the purpose of this explanation, let's say these 4 fingers are equal. If I put them and make a figure, that's a rhombus. I could change the angle. We're familiar with a square, but I don't have to be a square. As long as the 4 sides are equal, we could have like a diamond looking thing. As long as the 4 sides are equal, it's a rhombus. Right? The angles are not the same, it's just the sides are the same. Now the 4th side, the 4th figure, I'm going to combine a rectangle and a rhombus. So it has to be both. So it has to be rhombus, all the sides are equal. And it has to be a rectangle, which all the angles are 90. So all the sides have to be equal. All the angles have to be 90. So it's a combination of a rectangle and rhombus. And that one we know as square. So remember, squared has to be a rectangle and has to be a rhombus. It has to be both. If I see something that looks like a squared, but only the sides are equal, not the angles, then I'll call it a rhombus, because only the sides are equal. If I see something that looks like a square, but only the angles are equal, not the sides, then I call it a rectangle. But now if it's both rectangle and rhombus, I'll call it square. So, matter of fact, down the road, weeks from now, you guys will look, we're going to look at a figure that looks like a square, and I'm going to call it a rectangle. And I'll be like, oh, this follows that rules from a rectangle, because the square technically is a rectangle. Right? It's a rectangle and a rhombus. It's both. So technically, it is a rectangle. All right. Any questions on these? No? All right. Homework-wise, the way we're going to be looking at our homework, you're going to state the most specific name for each figure. Notice top and bottom are parallel. See my arrows? The sides are equal. Right? They're not parallel. They're equal. I'm using slashes. Isosceles trapezoid. Nice. Now, if I look at my example 2, top and bottom are parallel, left and right are parallel, but not all 4, obviously. How do we call that? Rectangle, the angles are 90.